Now that I've roughed out the saw with adaptive clearing, I need to apply finishing passes to get everything to size, starting with some 2D strategies on the 2D pocket and bore holes. I'll select a 2D pocket operation from the 2D dropdown to finish the sides and bottom of the front pocket. First, I'll select a flat end mill from my tool library to make sure those bottom corners are sharp. Next, I'll go to the Geometry tab where I need to choose the pocket to machine, so I'll select the open contour at the bottom of the pocket. In passes, I need to disable stock to leave to ensure the pocket is cut to the same size as the model. I'll hit OK to generate the toolpath, and I get a series of offset passes that will finish the bottom and sides of the pocket. To complete the front pocket, I also need to finish the shoulders, and this time I'll use a 2D contour. Fusion remembered my previous tool selection, so I can move on to the Geometry tab. I'll select the internal edges of the shoulders as the contours to machine and add a small tangential extension so that the tool enters and exits the cut at the cutting feed rate. I'll make sure stock to leave is off in the Passes tab and hit OK. To apply a bore toolpath to finish the bore holes, I'll select the operation from the 2D dropdown menu and go through the tabs. In the Geometry tab, I need to select the hole faces where I want to apply the bore. I can go to the Passes tab to adjust the angular step down or pitch, and then I'm ready to generate this toolpath. Last but not least, I want to apply the modeled chamfer to the outside of the mold. 2D chamfer creates chamfer passes that can detect the tool's distance from modeled geometry and automatically add retracts to avoid collisions. I'll choose 2D chamfer from the 2D dropdown, and notice that when I go to select a tool, the filter has updated to show me tools that can apply a chamfer. In the Geometry tab, I'll select the contours I want to apply a chamfer to. If the model isn't chamfered, I can select a sharp edge and enter a chamfer width later. If the chamfer is modeled in, I'll select the bottom contour. In the Passes tab, I can enter a chamfer width and a clearance value that Fusion must maintain between the tool and any geometry. The chamfer tip offset is the vertical distance from the chamfer to the tip of the tool to keep the cut as close to the outside of the tool as possible. I can use Edit Expression here to have this parameter update based on the selected tool and the entered chamfer width. Although not necessarily a finish pass, I'll also apply a drilling operation to the holes around the saw body. I'll select Drilling from the toolbar and choose a drill in the Tool tab. Under Geometry, I can select a hole by its cylindrical hole face or based on a point. To quickly select holes of the same size, I can check Select Same Diameter. In the Heights tab, the bottom height is automatically set to the hole bottom as defined by the bottom of the cylindrical face. I can adjust the bottom height to drill through by checking Drill Tip Through Bottom and entering an optional breakthrough depth. Under Passes, I can define a drilling cycle type. There are options like chip breaking, also known as peck drilling, full retract, and many others. If I select a cycle type other than wrap it out, I'm able to define the cycle parameters here. Now the 2D features are all finished, and I can move on to the saw body and 3D finish passes.